Welcome, students. We're going to start the semester by looking at solving equations, and then we're going to look into formulas, we're going to be graphing lines, and then we're going to move into some other topics. In the very beginning of the semester, a lot of these topics are going to be review for some of you. They're going to be things that you've already seen, but we're going to look at them again because we really want to make sure that we have a solid foundation for the work that we're doing this semester. We're going to start with solving equations because equations pop up in many math problems, and we want to make sure that we're very comfortable with solving equations. So we're going to start by talking about the rules of solving equations, the things that we're allowed to do, and then we're going to get some practice and talk about strategies. First, let's look at some examples of equations. These are some pretty basic ones. We'll see some more complicated ones in a bit. So 3x minus 2x equals 8 is an example of an equation. Y minus 2 equals 5 is an example. 3a equals 12, and then also 7 equals x. These are all examples of equations, and I've picked these examples because we're going to use them in just a little bit to demonstrate some properties. But each of these is an equation. We can recognize that because they have equal signs. And one of the things that we tend to do when we have equations is we tend to solve for the variable. So in this first equation, the variable is x, and what we could do is we could plug in any number we want for x. There's nothing stopping us from doing that. But what we want is we want the value of x that we can plug in so that when we evaluate the left-hand side, we end up getting 8 so that it's equal to the right-hand side. So when we're looking for a solution, we're looking for a number that we can substitute in for the variable to make the equation true. Now there's a few different things that we're allowed to do when we're solving equations, and we call these the properties of equality. These are the properties of equality, and we're going to go through them one at a time, and for each one we're going to look at an example to demonstrate that particular property. So the first property of equality says we may simplify either side of an equation. And the example we're going to use here is this first one, 3x minus 2x equals 8. If we ever have an equation that we're trying to solve, and there's a side where we can simplify, in this case we can combine those like terms, we are allowed to simplify the equation. So we can combine 3x and 2x. 3x minus 2x is 1x, which is just the same as x. So we can rewrite the equation as x equals 8. We have simplified the left-hand side by combining like terms. Another thing we can do is use the distributive property if it's appropriate in that situation. Now, we end up with an equation here that looks different from the original equation, but these equations are what we call equivalent, meaning they have the same set of solutions. So they look different, but they're going to have the same solution. And each of these properties of equality allows us to take an equation and rewrite it as an equivalent equation with the same solution. Now in this case, we have x equals 8, and whenever we have the variable alone on one side and a number on the other, like x equals 8, or x equals 3, or x equals -5, that is our solution, because that tells us x is equal to 8. So it gives us the value of x that works in that situation. We can check this, if we want, by substituting 8 into the original equation and seeing if we get a true equation. Let's do that here. We've got 3 times 8 minus 2 times 8 equals 8. Now on the left-hand side, we can do these multiplications. 3 times 8 is 24, minus 2 times 8 is 16. So we've got 24 minus 16 equals 8. And if we perform the subtraction on the left, 24 minus 16 is 8. So because the left and the right-hand sides are equal to each other, we know that our solution was correct. If we had gotten something here where the left and right-hand sides weren't equal to each other, it would tell us that we had made a mistake somewhere and we should try again. Now, I'm going to be honest with you. I am not going to check every single solution for every single equation that I solve in these videos, because that would make the videos much longer, and I really want us to get practice solving equations more than checking our solutions. We will check a few of them, but I will not check every single one. Also, I have solved these equations over and over and over again, so I am less likely to make mistakes than someone who hasn't been solving equations that often. I'd like to encourage you to check all of the solutions of your equations, even the ones that I do in the video, by pausing the video and taking the time to do that, so that you get the practice that you need checking your answers. Let's move on and look at the other properties of equality. The next property says we may add or subtract the same quantity on both sides of an equation. And the example we'll look at here is y minus 2 equals 5. Now, we saw in the last example that our goal is to get the variable alone on one side of the equation. If we look at this example, on the left-hand side we have y minus 2. If we want to get the y alone, we have to get rid of this 2 that's being subtracted from it. And in general, what we do when we're solving equations is the opposite of what's happening. So the variable is having 2 subtracted from it. The opposite of subtracting 2 is adding 2. So we're going to add 2 there, but the property says we may add or subtract the same quantity on both sides of an equation. So if we add 2 to the left-hand side, we're going to have to add 2 to the right-hand side also. Now on the left-hand side, negative 2 plus 2 is 0. Those cancel each other out, and we're left with just the y. On the right, 5 plus 2 is 7, and we end up with y equals 7, which is our solution. The reason we added 2 was because it's the opposite of subtracting 2. If the original problem was y plus 2, the opposite of adding 2 is subtracting 2. So we would subtract 2 in that situation. Anyway, we end up with y equals 7. Let's check this really quickly. If we substitute that in, it gives us 7 minus 2 equals 5. And if we evaluate 7 minus 2 on the left, that gives us 5. So we have 5 equals 5, and it checks. All right, next we're going to look at the third property of equality. We may multiply or divide both sides of an equation by the same non-zero quantity. The example we'll use here is 3a equals 12. Now, 3a means 3 times a. So a is being multiplied by 3. If we want to get it alone, we have to do the opposite, which is divide by 3. But if we divide the left-hand side by 3, we also have to divide the right-hand side by 3. On the left, 3a divided by 3 gives us a. On the right, 12 divided by 3 gives us 4. And so we get our solution, a equals 4. Really quickly, I want to point out it says that we may multiply or divide both sides by the same non-zero quantity. We're not allowed to multiply or divide both sides of an equation by 0. That would be bad. If we took 3a equals 12 and we multiplied both sides by 0, 0 times 3a is 0, 0 times 12 is 0, and we get 0 equals 0, and we've effectively lost all of the information we had in the problem. This new equation is not equivalent to the original equation, and so we're not allowed to multiply both sides by 0. We also can't divide both sides by 0 because we're not allowed to divide by 0 ever. That gives us something that's undefined. So be careful when you're using this property. You can only multiply or divide by something that's not 0. And then lastly, we have a rule that says we may switch the two sides of an equation. For example, if we have 7 equals x, we can switch these two sides and rewrite it as x equals 7. Now, you don't have to do that. You're allowed to leave the variable on the right-hand side. That's perfectly fine. But we're creating this list of the things that we can do that give us an equivalent equation. And so we want to make sure that we include all of the things on the list that we might end up needing to use. So this is included on the list. It may have been something that's obvious to you. It may be something that you don't need to use, but we're going to keep it there so that we're all on the same page. Now, these examples that we've just done are the most basic examples of solving equations. Each one only required one step. We're going to be looking at solving equations that will require 2, 3, 4, 5, 6, or 7 steps. So there's a link below these videos that will link you to several example problems that you can go through, and you can go through as many of them as you need to get lots of practice in figuring out what steps you need to take to solve equations, what order you should do things in, the best strategies, etc. Also, in the next video on this page, we're going to go through solving equations that have fractions in them, which is a bit more complicated, and we're going to look at situations where it's impossible to get the variable alone on one side, and some interesting things happen. So please take your time going through the example videos, going through the next instructional video, and really make sure that you understand the different examples that we go through.